In this video, we shall discuss the answer key to assignment number CM22M100101. I hope it will help you out. The students who are new to this channel who want to download assignment as PDF, please check link in description below. So, without much delay, let us start. The largest number which divides 71 and 126, leaving remainders 6 and 9 respectively is. Solution. To find this largest number, first, let us subtract 6 from 71 and 9 from 126. That is 71 minus 6 equals 65. And 126 minus 9 equals 117. Therefore, required largest number dividing 65 and 117 is their HCF. Using prime factorization method. Therefore, 65 equals 5 into 13. And 117 equals 3 squared into 13. So required HCF of 65, 117 is 13. That is, required largest number is 13. The least number that is divisible by all the numbers from 1 to 10, both inclusive, is. Solution. The least number divisible by all the numbers from 1 to 10 will be the LCM of 1 to 10. That is 2520. If the HCF of 85 and 153 is expressible in the form 85m minus 153, then the value of m is. Solution. Given is 85 equals 5 times 17 and 153 equals 3 squared times 17. Therefore HCF of 85 and 153 is 17. Now according to question, 17 equals 85m minus 153, that is m equals 2. If x equals 2 cubed times 3 times 5 squared, y equals 2 squared times 3 cubed, then HCF of x and y is. Solution. Given as x equals 2 cubed times 3 times 5 squared and y equals 2 squared times 3 cubed. Therefore HCF of x and y is 2 squared times 3 equals 12. If least prime factor of a is 3 and least prime factor of b is 7, the least prime factor of a plus b is. Solution. Given is 3 is the least prime factor of a. That means the number a is odd, similarly as 7 is the least prime factor of b. That means the number b is also odd. Hence a plus b is even. Because odd plus odd equals even. Therefore, the least prime factor of a plus b is 2. Because even numbers are multiple of 2. If a and b are two odd positive integers such that a greater than b, then prove that one of the two numbers a plus b divided by 2 and a minus b divided by 2 is odd and other is even. Solution. Given is, a and b are odd. Therefore, a plus b is even, also a minus b is even. Now if a plus b divided by 2 is odd, let a equals 2m plus 1 and b equals 2n plus 1. It implies a plus b divided by 2 is equal to 2m plus 1 plus 2n plus 1 divided by 2, equals m plus n plus 1 equals odd. So, both m, n are even or odd. Now, a minus b divided by 2 is equal to 2m plus 1 minus 2 minus 1 divided by 2 equals m minus n. As both m, n are even or odd, m minus n will always be even. Therefore, a plus b divided by 2 is odd and a minus b divided by 2 is even. Write whether 2 square root of 45 plus 3 square root of 20 divided by 2 square root of 5 on simplification gives a rational or an irrational number. Solution. Given is 2 square root of 45 plus 3 square root of 20 divided by 2 square root of 5 is equal to 2 into 5 square root of 3 plus 3 into 2 square root of 5 divided 2 square root of 5, which is equal to 10 square root of 3 plus 6 square root of 5 divided by 2 square root of 5. It implies 10 square root of 3 plus 6 square root of 5 divided by 2 square root of 5 multiplied and divided by square root of 5 equals 10 square root of 15 plus 30 divided by 10, after cancelling 10, gives answer equal to square root of 15 plus 3, which is an irrational number. Find the smallest number which leaves remainders 8 and 12 when divides by 28 and 32 respectively. Solution. Let us assume x be the smallest number which leaves remainders 8 and 12 when divided by 28 and 32 respectively. So, x minus 8 is divisible by 28 and x minus 12 is divisible by 32. But, if we add 20 to the x, then, new remainder will be 8 plus 20 is equal to 28, which is divided by 28, and 12 plus 20 is equal to 32, which is divisible by 32. That means, x plus 20 is divisible by both numbers, and it is the smallest such number. So, x plus 20 is LCM of 28 and 32. Now, finding LCM of 28 and 32. Using prime factorization method. 28 equals 2 squared times 7 and 32 equals 2 power 5. LCM equals 2 power 5 times 7 equals 224. That is x plus 20 equals 224. It implies x equals 204. Therefore, 204 is the smallest number which leaves remainders 8 and 12 when divided by 28 and 32 respectively. If the HCF of 408 and 1032 is expressible in the form 1032m minus 408 into 5, find m. Solution. Given is 408 and 1032. Using prime factorization method. 408 equals 2 cubed times 3 times 17 and 1032 equals 2 cubed times 3 times 43. So HCF of 408 and 1032 is 2 cubed times 3 equals 24. According to question, 1032m minus 408 into 5 is equal to HCF of these number. That is 1032m minus 408 into 5 is equal to 24. On solving, we get m equals 2. Can two numbers have 16 as their HCF and 380 as their LCM? Give reason. Solution: no, two numbers cannot have 16 as their HCF and 380 as their LCM. Because HCF of the numbers is always a factor of the LCM. And here 16 is not a factor of 380. Therefore, it is not possible. Let k be the greatest number that will divide 1305, 4665, and 6905, leaving the same remainder in each case. Find the sum of the digits in K. Solution. Required number K equals HCF of 6905 minus 4665, 4665 minus 1305, and 6905 minus 1305 equals HCF of 2240, 3360, and 5600. Using prime factorization method. 2240 equals 2 power 6 by 5 by 7. 3360 equals 2 power 5 times 3 times 5 times 7. 5600 equals 2 power 5 times 5 power 2 times 7. HCF equals 2 power 5 times 5 times 7 equals 1120. Sum of digits in K equals 1 plus 1 plus 2 plus 0, that equals 4. A mason has to fit a bathroom with square tiles of the largest possible size. The size of the bathroom is 10 feet by 8 feet. What would be the size in inches of the tiles required that has to be cut, and how many such tiles are required? Solution. Given size of bathroom equals 10 feet into 8 feet. As we know that, 1 foot equals 12 inches. Therefore, size of the bathroom equals 10 by 12 inch by 8 by 12 inch equals 120 inch by 96 inch. The largest size of tile required equals HCF of 120 and 96. Using prime factorization method. 120 equals 2 power 3 times 3 times 5. 96 equals 2 power 5 times 3. Therefore HCF equals 2 power 3 times 3 equals 24. Therefore largest size of tile required equals 24 inches by 24 inches. Now, number of tiles required is equal to area of bathroom divided by area of a tile. Therefore number of tiles required equal to 120 into 96 divided by 24 into 24, that is equal to 20. Therefore, number of tiles required equals 20. 15 pastries and 12 biscuits packets have been donated for a school fete. These are to be packed in several smaller identical boxes with the same number of pastries and biscuits packets in each. How many biscuit packets and how many pastries will each box contain? Solution. Given number of pastries packets equals 15 and biscuit packets equals 12. To find same number of pastries and biscuit packets in boxes, we need to find HCF of 15 and 12. Using prime factorization method. 15 equals 3 times 5 and 12 equals 2 squared times 3. Therefore HCF of 15 and 12 equals 3. That is number of small identical boxes equals 3. Therefore number of pastries packets in each box equals 15 divided by 3 is equal to 5. And number of biscuit packets in each box equals 12 divided by 3 is equal to 4.